So, okay, the session is started. Okay, Jim, can you hear me?
Yep, I see a speakerphone.
Good, great. So we are continuing session. We are going to have a presentation by Jim Logan, who is IOF member for a long time. He is. We have to turn off.
We need someone tall.
Oh,
all right. Okay, two euros.
Jim Logan is with the Soul Systems, 3DS Systems. He is also a developer of Camel software for knowledge modeling. I think he can tell us a little bit more about himself. And his presentation is about risks in making something. So please, Jim, introduce yourself and your topic.
Thank you.
You should be able to share your screen.
I think I'm sharing my background right now. Can you see?
Also, this is your in some which ocean is that? Is California?
I think it is. What is this? Big Sur, maybe.
Big Sur. Okay.
I'm not sure. Let me see if my videos work. Oh, it is working. I see myself. Okay.
Yeah.
Let
me see. Okay. We are sharing screen on our projector. And go ahead. Now what 15, 20 minutes?
Okay. So can you see my screen?
Yes.
All right, great. Okay. Well, hello, everyone. It's a pleasure to speak to you today. My name is Jim Logan. Thanks for the introduction. And like you said, I work for a company called Dassault Systems. So let me give you a brief history. Back in 2014, I joined a company called No Magic. At the end of that year, I created a proof of concept for a tool that would help me create ontologies with subject matter experts. I wished I had had this tool when I was consulting for the US government in my earlier years. The No Magic CTO encouraged me to turn my proof of concept into a product that would augment our already well-known Cameo suite of tools for system engineering and enterprise architecture. 2015 was the first public release of the Cameo concept modeler. Yes, I'm aware that some people dislike the term concept, but it keeps people from being scared of the big O word. In 2018, No Magic was acquired by Dassault Systems, the company I work for now. I've been working with the iOS since the Oslo meeting in February 2019, when everybody was asking me if I knew Chris Will. I had never met him before. I've been contributing to several working groups, including production planning and scheduling, core, system engineering, and supply chain, as well as the architecture task group. One thing that's bothered me for a while is how to account for things that occur in the future. Things like contractual commitments, scheduled loan payments, future calendar events or goals. The problem is that an event is something that actually happens, but a scheduled event is an intention for something to happen. We can't just rely on the open world assumption because there may be consequences when a future event fails to satisfy an intention. For example, one can be sued for failing to deliver, one can go bankrupt, an actual meeting may start late, and one can fail to reach a goal. Another thing that has been bothering me is how a design can sometimes bring a namesake universal into existence. An architecture for a perpetual motion machine can fail to bring a universal into existence, but a design for a 2022 Toyota Camry did bring a universal into existence when the first car rolled off the assembly line. Also, having a relation referred to a universal came up in a discussion among some of us in the IOF supply chain working group. Can a supply agreement for a future model of Tesla cars refer to a universal? Over the past few months, I did a literature review on the topic of cybersecurity, which is all about preventing potential attacks in the future. I found some very approachable papers within the UFO ecosystem. For anyone who's unfamiliar, UFO stands for the Unified Foundational Ontology. I've been slowly familiarizing myself with UFO for several years now, anyway, for other reasons. From those papers, I've cobbled together a way of accounting for some things in an ontology that you might find useful. I put references at the end of the presentation in case you're interested in retracing my steps. One paper in particular got me up to speed on UFO B and C in the context of a software process ontology. It explained that UFO B is an ontology of perdurance, also known as occurrence, and UFO C is an ontology of social entities that is built on top of UFO A and UFO B. Anyway, I hope you find this presentation useful, and the UFO guys don't want to kill me, so here we go. Okay, so now that I've made some of you hungry with the thought of eating blueberry pie, I'd like to use this as an example to tell you about goals, plans, and prevention. My kids had a desire. They wanted to make a blueberry pie exactly like grandma does. I had a different desire. I generally want to lose weight and stay trim. A sugary blueberry pie doesn't help me to do that. The kids and I had different opinions about making blueberry pie. The question is, ontologically, what existed in this situation? What kind of thing is a recipe? How does it relate to a future making of a blueberry pie? There's a similar duality that exists in cybersecurity. Imagine a situation where a hacker steals your money from your bank account. That's his goal, but it's something that you'd like to prevent. So just as we need ingredients for blueberry pie, we need ingredients for an ontology. Those ingredients are mostly axiomatized terms that I've taken from UFO. Before we get into that, though, I'd like to introduce the ontology notation I'm about to show you. That notation is implemented in my ontology tool. Now, as for the name of my ontology tool, Dassault renamed it recently as a rebranding after the acquisition. The old name was the Cameo Concept Modeler, not to be confused with the characterization methodology ontology pronounced Cameo. The new name is the Magic Concept Modeler. Well, let's just call it the Concept Modeler for short. And I'm well aware that Barry Smith outlaws the word concept, but the word ontology scares people. Since the IOF uses BFO upper ontology, let me show you that first, rendered in the Concept Modeler. Afterwards, I'll show you the blueberry pie making owl ontology.
Hello, Jim. Can you hear me?
Yes.
Jim, hello?
Can you hear me? Can you hear me?
Yes, we have some network problems, so give us a minute. We are trying to fix it.
Okay.
Yes, Jim, you can proceed. I think you need to share the screen again.
That's his screen.
Yes, we can see your screen.
Okay. So should I, what was the last thing that you remember me saying?
About 2 minutes. Can you rewind for 2 minutes?
Okay, sure. Let me share my screen again.
And share screen and you were showing these 3 or 4 papers. We didn't do that.
Oh, we have to go back a little bit more then.
We didn't do that. No.
Okay.
This one.
Right here.
That's where we lost you.
Ah, okay. It's been a while. Okay. So let me just say that that I found some approachable papers, and for anybody who's unfamiliar, UFO stands for the Unified Foundational Ontology. I've been slowly familiarizing myself with it for several years for other reasons. From those papers, I've cobbled together a way of accounting for some things in an ontology that you might find useful. I put references at the end in case you're interested in retracing my steps. The one paper in particular got me up to speed on what's called UFO-B and UFO-C in the context of a software process ontology. It explained that UFO-B is an ontology of perdurance, also known as occurrence, and UFO-C is an ontology of social entities that's built on top of UFO-A and UFO-B. Anyway, I hope you find this presentation useful, and the UFO guys don't want to kill me. So here we go. Can you see? Can you still see?
Yes.
Okay, good. So now that I made some of you hungry with the thought of eating blueberry pie, I'd like to use this as an example to tell you about goals, plans, and prevention. So my kids had a desire. They wanted to make a blueberry pie exactly like grandma does. I had a different desire. I generally want to stay trim and lose weight. A sugary blueberry pie doesn't help much with that. The kids and I had different opinions about making blueberry pie. The question is, ontologically, what existed in this situation? What kind of thing is a recipe? How does it relate to a future making of a blueberry pie? There's a similar duality that exists in cybersecurity. Imagine a situation where a hacker steals your money from your bank account. That's his goal, but it's something that you'd like to prevent. Sorry?
Yeah,
I thought I
okay.
heard something. Okay. Just as we need ingredients for blueberry pie, we need ingredients for an ontology. Those ingredients are mostly axiomatized terms that I've taken from UFO. Before we get into that, though, I'd like to introduce the ontology notation I'm about to show you. That notation is implemented in my ontology tool. Now, as for the name of the ontology tool, Dassault renamed it as part of a rebranding after the acquisition. The old name was the Cameo Concept Modeler, not to be confused with the characterization methodology ontology produced Cameo. The new name is the Magic Concept Modeler. Let's just call it the Concept Modeler for short. And by the way, I'm well aware that Barry Smith outlaws the word concept, but the word ontology scares people. So anyway, since the IOF uses the BFO upper ontology, let me show you that first, rendered in the concept modeler. It'll only take a second. Afterwards, I'll show you the blueberry pie making owl ontology. So here's the BFO 2020 taxonomy. I think it's useful to build on standards. I'm aware that one person in the IOF really hates UML, but the notation's an ISO standard. It's ISO 19505. The concept modeler is an extension to UML that fills in some gaps needed to represent an ontology faithfully. Some examples of those gaps are anonymous classes, necessary and sufficient conditions, exact intersections, restrictions, property chains. The concept modeler also has a library of commonly used ontologies and diagrams that make them easier to understand. So here you can see a rendition of BFO 2020 from the new ISO standard. And here's all the rest of BFO 2020. Maybe it's a little bit less intimidating than you thought it would be. I don't expect you to see all the details, but the concept modeler expresses restrictions by reusing UML's ability to subset and redefine properties. That lets us express things like some of the successors must be of a type, or all of the successors must be of a type. The concept modeler library also offers CCO 1.2. That's the Common Core ontology used in the US military and in life sciences. As you may already know, the IOF core borrowed some things from CCO. In the interest of time, I'll just mention that the concept modeler library also contains BFO2, which is still heavily used in life sciences, and Dolce, which will make Barry Smith hiss, and the gentle version of UFO and OWL called GUFO. I'll be using parts of GUFO for the blueberry pie making ontology, I keep promising you. I keep hearing something. Somebody trying to speak?
And we lost you on main screen. I'm actually broadcasting you on my laptop.
Okay, are you still seeing?
I'm seeing. I don't know if everybody is seeing. So
take the cable. Maybe you can use any ROM on the.
Yeah, move the HDMI cable over to your laptop.
Yeah, that's it. So we need the sound.
I lost.
The sound's fine.
Oh.
Are you speaking?
No, I'm waiting for you guys to.
Can you connect the HDMI to your laptop?
I don't want to mess up with this.
Just the screen cable.
It's already messed up. So.
This is an HDMI. This is some DVI.
Oh, that won't
work.
Yeah.
Right. There you go. That's.
The DVI is not HDMI.
That's something we go.
Too complex setup for me. Hold on, James. So we are seeking help.
Okay.
At least we can hear and diagnose issues. You are all ready. So what's that? Okay.
You can always stick it back on.
Okay, continue.
Okay,
continue.
Okay, can you hear me now?
I was going to use that microphone.
Can you hear me? Can you hear me?
What are you trying to do?
Turn on the sound.
Okay, can you hear me now?
Yes.
Sound.
Can you hear me?
Continue. Leave it there. Yes.
I'm hearing noises from the room, I think. Dushan, can you go on mute? Okay, I think I'll continue. Okay, so on this slide, I was saying that the concept modeler library, I'm hearing noise. Can you hear me?
Keep talking.
Okay, great. So the concept modeler library also offers CCO 1.2. That's the Common Core Ontology used in the US military and in life sciences. As you may already know, the IOF4 borrowed some things from CCO. In the interest of times, I'll just mention the BFO2 and Dolce and the gentle version of UFO and OWL called GUFO. I'll be using parts of GUFO for the blueberry pie making ontology I keep promising you. I have just 2 more quick slides before I get back to that, so please bear with me for a few more seconds. So I want to point out that the concept modeler has the ability to automatically draw and refresh what we call a defining diagram. Every class is hyperlinked to one diagram that shows all its details. When a class appears on any other non-defining diagram, it's automatically collapsed and faded for you. These defining diagrams and pop-up explanations make it easier to learn an ontology. I know these diagrams help because I used to create them manually for my consulting customers a long time ago. I also want to point out very quickly that the concept modeler can automatically explain the axioms in an ontology so non-technical people can validate them in plain English. If I recall correctly, this was a definition I generated a long time ago from the financial industry business ontology. You'll see both a model-generated definition along with whatever annotation properties were chosen. You'll see here that all the necessary conditions for the term contract is explained in bulleted form. Okay, now that you've seen some of what the concept modeler does and what its notation looks like, I'd like to explain the blueberry pie making ontology from the bottom up. By bottom up, I mean using example OWL instances. The concept modeler leverages standard UML instance specifications for this. I hope you'll find instances clearer than looking at the classes first. Each yellow box with underlined text represents an instance. In the text, the name of the instance is written before the colon and the name of its classes comes after the colon. So let's start with Molly. Molly has a desire that adheres in her, labeled D1. D1 is a proposition as propositional content. That proposition is, let's make blueberry pie. For the moment, let's ignore that this proposition is also a goal. I'll get to that in a second. Just like Molly, Andy and Jim, that's me, also have desires D2 and D3 for the same propositional content. Now, a desire can be assessed. Note that I'm using the term assessing and avoiding the term assessment because it could be misunderstood as the result of the assessing. Everything still good?
Still small.
Let's just mute our side and you can.
Go ahead.
Okay. So the process of assessing Molly's desire mapped from her desire, projected it as the quale called high desire, and then recorded that as a measurement M1. The process of assessing my desire mapped from my desire, projected it as the quale called low desire, and then recorded that as measurement M2. Let's skip the assessing of Andy's desire because it works the same as Molly's. You can see that both qualia are proper parts of a low resolution value space of high, medium, and low. We could just as easily use a different value space using numbers between 1 and 10, or using a pain scale you may have seen in the hospital from happy face to agonized face. In that case, mine would probably look something like this. I'll also point out that we can assess each desire multiple times. Okay, after the kids convinced me to give in addition to having our different desires, now we have 3 more mental moments. You notice that the rectangles in the middle of the diagram each have a subtle comma between intention and unfulfilled commitment near the upper right of each rectangle. This tells us that I1, I2, and I3 each instantiate 2 classes. That's because in UFO-C, every intention is both a mental moment and a commitment that's either fulfilled or unfulfilled. Here's a quick peek at the relevant defining diagram for intention to show you how it's defined. The vertical generalization arrows coming out of the rectangle labeled intention tells us that every intention is both a mental moment and a commitment. The bottom complete disjoint generalization set tells us that a commitment is exactly the union of either a fulfilled commitment or an unfulfilled commitment. After the kids and I established a common goal, we got to work. The events unfolded as you might expect. Andy participated in getting the ingredients, Molly participated in combining them, and I participated in the baking and the reading of the recipe card. The recipe card is one of the places where Grandma's recipe was concretized. Both my reading participation and the recipe card's being read participation were part of the complex recipe following event. Eventually, the entire Making Blueberry Pie event had unfolded and our blueberry pie was created. One interesting thing happened when the blueberry pie was ready. Nobody had ever followed this recipe before. It turns out that Grandma had tweaked it slightly as she wrote it down on the recipe card. A universal like making Grandma's blueberry pie requires at least 1 instance. We made the very first instance that day. Here's the class view explaining event type creation. When a first pie comes into existence, an instance of a recipe prescribed an instance of event type called making Grandma's blueberry pie. The dashed line here means that it's an instance of relationship between the 2 classes themselves, not between their instances. Here's a partial instance view.
Are you there? Issue there. Jim, can you hear us? We cannot hear you. But he said that he's in.
You switch to a different vector and muted this one, then they will skip out this one. So this stuff is unmuted.
So you switched. Who is coming? Excuse me? Okay. But we cannot hear from here.
No, he left meeting. I don't know why. You know, he's back, but we cannot hear him. He's not sharing screen. I don't know if he is aware of that. And we switch temporarily to my screen.
You are on speaker.
I'm on speaker. Yeah, we are using this one.
Because this one dropped out first.
Oh, okay. Okay.
Can you start talking, Jim?
He is not talking. Because if you talk, then you
Oh, yeah.
see them.
Oh, I have to talk to see that. I see.
Yeah, he's not talking.
He's not talking.
Yeah, it's not. I mean, we are doing all right from our side, I can say.
I know, but I mean, so.
Yeah, everything all right from our side. Hello, Jim. Hello.
Yes, showing our voice. It's not
Yes.
showing his noise. I'm sending a message.
Oh, he dropped off. Yeah.
Yeah, he left stage
Mhm.
again.
It seems like he has some connection problem. It's not
Possible. Yeah, it was long day for that computer.
Oh, he's tired. He's tired himself, but it is tired.
He started.
Let me know if anyone started contact person.
I sent him a message
Thank you.
and asked him to call me.
Are we still following the schedule or we are shifting everything?
A little bit late.
A little bit postponed.
15 minutes or so?
15, 20, like, yeah.
Okay, all right.
I'll be very glad if it is just 15. But then, yeah,
Fair warning.
It is 15.
Fair warning.
No, I'm wrong. What do you expect?
I don't know.
No. If we can have another. No.
Yeah, he dropped completely. So.
Yeah, maybe that was problem was on his side, so he's maybe trying to rejoin.
I would recommend that we start panel and then finish.
Yeah.
I don't think we have to wait. Can you call Arco to start panel? So I think. So that's one. Everybody agrees? Just small group. So we have a. Let's start panel. Panel is where do we go with PPS working group right now? And panelists are. Jim was supposed to be one of them. Fernando and Mara. Abel, right? Yes, there's still an Abel. I think we go to panel.
Let's go.
Yeah.
But then Jim is in a panel, right?
He's in the panel, but I mean, we don't have him.
Okay.
If he.
Who was in the lobby?
No, this is Jim Logan, who was.
Is the other Jim.
He's from USA. Yeah. Joining from USA.
It is definitely he's having some connection troubles.
So at least for panel, I don't think we have to come here, but if you can just.
Okay, so let me start sharing. How I'm in session. I cannot share screen.
Yeah.
I don't need to share screen. Okay, I do. Actually, I do share. No, but this is not for online. This is only for room. Good. So we have Fernando from Airbus and M&M. We have Farhad. Why don't you join?
I joined from here. How about that?
That's okay, no problem. And we have Mara from Brazil. Topic is what is next for production planning and scheduling in general and production planning and scheduling group. I drafted 4 questions that I want to answer everybody. With all IoT, sensors, industry, Do we need planning? Do we need design? This is important in context of digital artifacts. How do we make real-time decisions from ontology point of view? How do we capture necessary feedback from one scope to the previous, from planning to design, from design to requirements, etc.? And what is role of digital manufacturing twin in design and planning? They don't appear to be much about ontologies, but I think my state, I want to hear from panelists, what do you think of this? So pick any of them and give us your 5 minutes. Whoever wants to go first. I'm looking at you, Fernando. So
thanks, Dusan. Yes, that seems that there is a lot of ontologies there, but it is okay. Of course, IoT sensors and all things around Industry 4.0 will give us a different look of the manufacturing plants. Because before all this information coming in real time from the plant, we have the information coming from filled by the workers and not in real time. And all this information that we had before doesn't give us the possibility to take real-time decisions, because normally it was not updated. Okay. Today, if we have information on real time, we can give different decisions on our planning, and probably we can prevent activities, or we can rearrange scheduling in order to better production. Okay?
Mm-hmm.
Do you think that I feel with the others, or
no,
maybe round?
Let's go. First question, Farhad.
Well, there is already a sensor ontology by Sosa. Have you heard of
Your
it?
SSN?
Have
Yeah.
used it.
Yeah, I've used it.
Yes.
Yeah, so I mean, from my experience, it's very difficult to understand some of their key models, especially observation model.
Mm-hmm.
Yeah, so we tried to kind of reuse their approach, but it didn't work. So my point is that we need better ontologies for sensors and better ontologies for observation and measurement, so to support a wide range of viewpoints industry. So do we need design? Well, we need to design ontology, but Dusan, let me ask, do we need design, not exactly.
Not design ontology, design process. If everything is, if you're making decisions in real time, can we do without design? Keep talking. I think this is Jim. Hello?
Hi, it's Jim.
What happened?
Yeah. So, yeah, we need design of the process for data collection, obviously, but it's a general, we cannot have a general process that can be applied to all situations, obviously. So, yeah, so we need design, but it's not an ontology problem. That design issue is a different issue. It's outside the scope of ontology. So he's not on that.
Okay, I go from where you are.
Yeah.
Where you are. Indeed, we have used the sensor ontology, those that you mentioned from Susan. I got the same impression that some of the concepts were barely defined.
Can you hear us?
Generic.
Yeah.
But for our point of view, that we are not people, we don't have people from design engineer, from IoT, resource design. It was very useful because they provide us with a general view about how to split the domain in entities and so on, and then we just fill the gap of things that we consider that was not clear.
Mm-hmm.
So having a previous ontology is better than starting from scratch.
Absolutely.
Because starting from scratch, it takes longer, it's a lot of discussion, different views, and the chance of having a wrong view because you don't have the expert in that moment is very big. So it was useful. Could be better, yes, better, maybe we ourselves have done some improvement over it. I cannot tell you because it was my doctors that have worked with that. So it's quite okay. Related to this problem about real-time decision, indeed, we also receive data from sensors in spreadsheet. You know, we don't receive real time. It's a large plant or a large process with a lot of data providers. We receive has tables, and we use this table to create a kind of temporal series, and then this temporal series we extract patterns, and then we try to anticipate problems and decision and production. So that's the point. So for us, the part of IoT, it was not a crucial part that we need a strong detail and so on. We needed to describe the information in order to do this, to bring to a uniform view for the decision taker. So it's good if everything is already modeled, but we all together have not coped with this until now, and having something is better than nothing.
Okay, let's hear Jim's comment on number one.
Oh, so the question is, do we need planning for sensors?
No, we are getting real-time data from IoT sensors. Do we need planning activities, design activities, not planning?
Well, yeah, I think that in a previous session, someone was talking about how you've got GDPR issues, and customers don't want you collecting data unless you can tell them what you're going to do with it. So I think that that you do need some amount of planning to be able to to articulate to the users what you're going to do with their data. So there's at least that.
Okay. How do we make real-time decisions from ontology point of view? Go ahead, make again circle,
okay,
go around.
I think based on the previous discussion, that the data coming from the IoT network, that you mentioned that you receive in a spreadsheet, not in real time. Sometimes you can use in real time. I think there is several different ranges. Mm-hmm. Okay. Of course, most of the information that we receive today from the ERP, in particular the starting of the operation, the finish of the operation, the machine downtime, down, and so should be treated in real time because are really important for the planning. Some others, like machine utilization, or some like waiting times or whatever, should be treated after words in order to improve the system and to create knowledge or information to do that. This is because I think real-time decisions, important real-time decisions, are more or less the same that we have today, but based on that we have on real-time. But I don't feel that the planning system will change in terms of information. Yes, will change in terms of the timing which the information is changing. You know?
Okay.
Well, so we need to move reasoning like to the edge, right? If you want to make real-time decision. So suppose you have a shop floor and you change the tool or fixture and you want to quickly, based on the new configuration, just make a decision that how the capabilities of the machine has changed. So, I mean, that's not possible right now with the current technology to do it in real time. So reasoners are not that advanced, or they are not at the level that can be scaled to the shop floor. So that's the challenge. So if you want to, by decision making and using ontology to support decision making, mainly in reasoning, right? So
yeah, exactly. Yeah.
So where does that happen? Do we mean close real time or real time?
It's right time indeed. It's not real time. The definition correct is right time because it's a
right
short
time.
interval,
Yes.
but it's not real time.
Yeah. So to be realistic, maybe it's outside the capabilities of current state of ontology to enable that. So unless, for example, I don't know if you are familiar with RDFX. So there is a platform developed by Oxford University. So they have a reasoner, and now they claim that the reasoner can be installed on a Raspberry Pi. So then you can attach your Raspberry Pi to a sensor and just quickly just do the reasoning using
edge reasoning,
search engine or reasoning engine. Yeah, I've not explored that, but it's all at prototyping stage. Right? So it's not
small process.
Yeah, it's small process with a small data like bandwidth. Yeah, so at a scale, yeah, based on current state of industry, I guess it's too early to get to that point.
I'm not the person on planning on design. Indeed, I work more with operation. That's why I know that is right time, because we don't receive the information from sensors or the production information. It's not coming in real time in the technical term. It comes with some interval, and we produce this temporal series, and then these temporal series are used for support decisions. So sometimes when the problem happen, they don't get the signs if the signs were happening in a short time. That's the reality, at least in the problem that I work with. So we use ontology in this scenario first because that sensor providers, they provide us the tables with many different formats. They have their own database formats, and then we receive that and we need to map to another format, and then we need to integrate with some local operation that is produced by Petrobras itself, by Libra itself. Then we use the modeling of the ontology to choose from the table what is useful for that group of operation. We work with, we call flow assurance, which is the people that guarantee that the oil is coming out of the well. So we choose the information that we need, we bring to a uniform view, we provide them with some beautiful visualization tool to choose, and then they take the decision in the moment that they can realize that something needs to be changed in the plan. It's like this. So ontology plays the provider of the uniform view, but not the reasoning one. It's not the ontology reasoning that is telling them to open this, close this, stop this production. Call the fireman and so on.
Yeah. Jim, you want to pitch in on second one?
Yeah, I'd like to say some things here. So I have a strange perspective on this. We're using a realist ontology. We're basing everything on BFO, and as I see it, I'd be willing. I'm hoping that somebody can have a discussion with me and tell me why I'm wrong. But I see it that there's two parts to a realist ontologies. There's the actual things, and then there's measurements of the actual things. And we've got measurements versus qualities, for example. And it seems to me that only part of that is relevant as a knowledge graph. That the first part, the real things, plays a role with integration, so that we know what it is that we're talking about. But after you've done this integration, you figure out what you're talking about. As I see it, you've got information content entities that you're dealing with. Those are the measurements. And my question is, is it true that a knowledge graph provides a unified query and dashboard in the language of the subject matter experts? I think that's the role that what we're calling ontology plays in this scenario.
Okay.
I did not understand, Jim, what exactly you do with the knowledge graphs. What's the role?
Well, I'm drawing a distinction between an ontology and a knowledge graph, primarily because we're using a realist ontology. And if you think of a knowledge graph as being perhaps the subset of an ontology that is about the measurements and the observations about the things, those are the things, as I see it, that go into the knowledge graph that we can then query and run business intelligence dashboards on.
I'm not.
Does that make sense?
No, I really don't, because a knowledge graph can be any kind of relation that you would like to have
Sure.
emphasize or use over an ontology. So it's something to support search or reasoning or something like this. But the ontology itself is a hierarchy with a lot of axioms and restrictions. So I cannot see, I really cannot understand how do you are using. I'm not saying that is wrong. I am saying that I am not understanding how do you are used, because there are plenty of possibilities of using this.
Well, the way that I see it is that, in Protege, for example, you've got the T box and the A box. You got your instances and you got your classes and your properties or your relations. As I see it, the ontology, a realist ontology, only some small portion of that is going to be interesting for doing things like a dashboard and querying. Mm-hmm. So that subset is what I'm thinking is what the knowledge graph is going to have in it is a triple store, as some sort of a graph, Neo for J, something like this. I can't see that you'd need everything from a realist ontology in that knowledge graph.
No, you don't. Indeed, I do the same than you. We define a BFO specialization with the real entities, facilities, equipment, and so on, and then a strong and deep definition about measures of qualities that you have on this. Then you have the instance of these, the T box and the A box separated. And then for our application, the parts that the knowledge graph, in your case, are implementing, we are dealing with the software itself.
Yeah, I agree with that.
Okay. I'm going to try to skip next number 3, go to number 4, and this is related to my presentation earlier today. So what is the role of digital manufacturing twin? And I want to show also digital artifacts in design and planning. Particularly, I want to focus on digital manufacturing twin, when I mean digital twin of a factory, not only digital twin of a product. You want to go again first?
Yeah. Digital twin for manufacturing, or digital twin of the factory, or digital twin of the manufacturing assembly operations, or production. Digital twin is totally different to the product digital twin, of course. And to me today is a must to build a system, in particular to help in the design process, including in this design process not only the product design, also the industrial design.
Yeah. And
because both need to be done in parallel and working together, and the role of the digital manufacturing twin is critical in order to check and test the different solutions and to feedback all the different variants and all the different design solutions that you can do. Of course, this is has a strong relationship with the previous one, with the third, because to do that, you need to have the two magical words. One is digital continuity, the other one is interoperability.
Digital continuity.
And both are, to me, fully related with ontologies.
Yeah.
Okay.
And I wrote this question before I listened to Rebecca since Xiao Chen's presentation, but I think answer is there from Herba's perspective.
These are two magic words, and these two magic words are based on the use of ontologies, not only in different scopes, because if you can have a scope fully automated, fully digital, fully interoperability, but you need to connect the different scopes.
Yeah.
You need to have digital continuity along all the lines.
Okay.
And I think this is the key. And of course, in parallel, you have the digital manufacturing twin, that is basically the virtual manufacturing and assembly of the product. You have a virtual factory on your table.
So I think we have to create what I was advocating in my presentation. We have to basically come up with ontology for digital artifacts, because we are making digital model of whole factory, and we run a model, like you mentioned, simulation, that shows some performance, which is not real. It didn't happen, but this is what we want to happen.
Absolutely.
Okay.
Absolutely, and after one of the products of the digital manufacturing, of course, is the digital twin of the artifact that you are producing.
Yeah.
That probably, at least in complex products, is not always the same.
Yeah.
And you have identified the individual artifact that you produce.
Okay.
In cars, in chips, in aircraft, there is not two identical. Okay, we are not producing maybe other things that are always the same. No?
Let's try to finish in 5 minutes. You saw Varkos telling me 5 minutes. So Farhad 1 minute, Marat 1 minute, and Jim 2 minutes.
Well, I see more role in planning. So, for example, for preventive maintenance and corrective maintenance, or you need digital twins of this to collect data from equipment, plan for maintenance and schedule. In design, well, I'm not seeing many applications of digital twin in design, but I can see there are ways to use digital twin. But I use the example of MT Connect, the standard for collecting CNC information from real machine, and so that information is used in maintenance planning and asset management. But the question is, MT Connect itself is a standard, right? So, and all can understand the standard. Then do we need another ontology on top of the standard? I mean, what's the value of an ontology when we already have a standard for a digital twin of CNC?
So do you consider, that was my question, do you consider MT Connect implementation of a particular machine as a digital twin of that machine?
No. So it's just a data streaming, right? The MT Connect is a data standard. And in fact, if you attach that data standard to the model of the machine, then you have digital twin, right? But the point is that once you have a standard, so you can create digital twin of your machine using the same standard. Then what's ontology here? So I'm just playing devil advocate, right?
Yeah, I know.
If the standard cover your domain, you don't need an ontology. If the standard is well defined, I think that you don't need an ontology.
Yeah.
But,
my experience with it, in life cycle of IOF, we mentioned so many ISO numbers that I cannot remember all of them. 59, 26, 95, 88, ISA.
So that's the problem.
So,
we need a standard for standards. You know?
Yeah, that's exactly, yeah. So you want to pitch in on that?
I will skip from this, because design and plan is the I will call Arid from CIS Lab that's in the other room to answer that.
Okay, Jimmy, give you a last word.
Okay, so let me be a little bit controversial again. So sensor data is what I see as being measurements of qualities. But if you imagine an air traffic control system, if we disconnect that air traffic control system from an airplane, we get a video game. So therefore, in a realist ontology, there are distinct things. There's the air traffic control system video game, or the digital twin, and there's the real airplane. And I think that we need to keep them separate. And I think that the thing that the air traffic control video game has inside of it are these things purporting to be measurements of the qualities of an airplane. So there's this weird thing that's happening with ontologies. You know, if I click on an instance IRI and I use it as a URL, I get data, right? The data I get is some sort of an information content entity. And what is inside of those what is inside that information content entity? I think it's observations and measurements about the world. And we have this conflation about using an IRI to identify the data and the real thing at the same time. And in a realist ontology, you have to split these two things apart into an information content entity and the real thing that's up in the sky.
No, but many time in engineering, and I would say in all areas of engineering, we create things before we make them. We create digital artifacts before we make things, and these digital artifacts exist before we start push button for actual manufacturing. So I think this is I see role. I just want to conclude. So can we ask you first apology for these interruptions? You didn't have chance to finish. Can we ask you to send your slides to Arco and then try to share them with the group, or some format that we can get the rest of your presentation?
Okay. And how far did you guys see?
It's very pity. I think you started with good example. I'm looking forward to kind of learn more.
Okay,
So
I'll be happy to share.
Yeah. I think with that we can conclude. Thank you, all four of you. Good discussion. And thank you for staying the whole day in this hot room. Jim, we are going back to plenary, so probably you may want to join to different section.
Okay. All right. Thanks.
Good. Thank you. Thanks a lot.
Sure. Bye-bye.
Yeah, take it.